Alright, I'm going to start off by going over worksheets 39 and 40. You worked through your booklet earlier. You should have the link still to that video, so if at any point in time as you're working, if you find that you need to go back and look up those formulas, either in the video and see how they're applied, or in your booklet, feel free to do so. Going over worksheet 39, as I know sometimes it's difficult to see exactly how those are plugged in and exactly how to work through those, especially with surface area where it's not just a cut and dry formula every time. So I'm going to work through a few of these and show you how these work. So for this first one, we've got 3 sides. You need those dimensions. What we see here is that all sides are the same going all the way around, which means our length is the same as our width is the same as our height. What we're going to do is we're going to find the length of length and height, or length and width, depending on how you want to think of it, of one face. And since I know all the sides are the same, I'm going to multiply the area of that face times 6. Or if you found the area of each side and then added them together, would be the same thing that we did here in the video. So just depending on how you did that. So you set up 6 times 6, which is going to give you 36. Then I know that each of those sides has an area of 36 centimeters squared. Because as I said yesterday, units are important, and when we're talking about area, we need to make sure we're paying attention that we've got that measurement squared, because we're using 2 dimensions, not 3. So we now have 36 times the number of sides that have that area, which in this case is all of them. Gives us 216 centimeters squared. Which gives us our surface area. If you forgot that unit of measurement, that is important. And it needs to be squared, not cubed. Cubed tells us we're working with volume. So I need to have that 216 centimeters squared. Now for volume. Volume's pretty straightforward on this one. And what I'm going to do is I'm actually going to set it up in the formula the way you should have set it up. V equals length times width times height. So it should be V equals 6 times 6 times 6. Or in this case, be the same thing as 6 raised to the 3rd power. This still gives us 216 for our answer. But in this case, it's going to be centimeters cubed, because we're talking about volume. Now, it doesn't often happen that your surface area and your volume are the same, but that happens to be the case in this instance, and that's perfectly fine. Hopefully ones like that with those prisms were fairly straightforward for you, so I'm not going to spend a ton of time going over those. I know these other shapes are the ones that give most people problems. So I'm going to look at number 3. So the formula for surface area that you're given in the video for your booklet is pi times the diameter times the height plus 2 times pi times the radius squared. And as I stress multiple times in the video, there's a big difference between diameter and radius, and you need to know which one you have. In this case, we have a radius. Radius is halfway across, diameter is all the way across, and in this case we need both. So if we know radius is halfway across, we also need the diameter. We know we need to double that, which in this case is going to give us 8. Now it doesn't give us a unit of measurement, so we're going to leave it just as 8. So now I have all those pieces. I can plug those in. So I've got surface area equals pi times the diameter, which is 8, times the height, which is 8, plus 2 times pi times the radius, which is 4, squared. Now a little simplifying before you punch that straight in your calculator makes it a little easier to punch in. But if you don't want to do that, as long as you make sure you do your order of operations first and remember those parentheses, especially this one here. I need to make sure I square that 4 and I'm not trying to square something else. You should be good to put it in. But I'm going to simplify it a little bit just to show you how this works. If you'll treat pi and leave the symbol there and treat it almost like a variable, it's not. It's always the same number. But if you treat it a little bit like one, you can simplify, collect your 8 times 8 there, which is 64. Plus, we're going to do order of operations again. So I've got 4 squared. That's 4 times 4 gives me 16. I'm then going to multiply it by 2, which gives me 32. So I have 32 pi. That's a lot easier to punch into your calculator. Anytime you see the pi symbol, unless you have specific instructions to do otherwise, you need to use the pi key on your calculator. The pi key on your calculator is above the caret key, or if you're looking, and if you're not sure which one that is, if you don't remember, the caret key is below clear. It looks like an arrow pointing up, and it's in the blue, so you've got to hit second to get to it. Or depending on what color or kind of calculator, it may also be in the yellow. So you punch that in your calculator to get your final answer. Should give you a surface area of 301 point. Now it gives us 0.5928947, but it wants us to round to the tenths place, so that 59 becomes 6. And we don't know the units, so I'm just going to put units squared. If you didn't do that, that's a good habit to get into just to help you remember that you're dealing with surface area, so you're dealing with square units. I can't just put a squared over 301.6 because that's a completely different thing. That gives me an operation where I'm squaring that, and I don't want to square that. Now for the second part, that volume, and as I said, volume's really nice because across the board they've given you a formula that always works. Surface area changes just a little bit, but always figuring out the area of each individual side and add them together will get you there. But volume, you got a nice neat formula you can always plug into. This one we've got volume equals pi times r squared times height. Again, we got r, and I'm going to re-emphasize r means radius. That's halfway across, so we're dealing with the 4 this time, not the 8. So I'm going to plug that in. Everything I know, v equals pi times my radius, which is 4, squared, times my height, which is 8. Now that's ready for my calculator. Again, if I remember to use my parentheses, it'll make my life a little easier. If you want to simplify ahead of time, you can. If you do that, it's 4 squared, which is 16. 16 times 8 is 128. So you get 128 pi. The reason I'm showing you that is because it would be possible for your EOC to leave it in terms of pi instead of giving you a decimal. Most of the time they're wanting a decimal and make sure you know how to round, but it would at least be possible for them to show you that. If you do see that, don't panic. You could always check it and see and type in your answers and see which one gets the same decimal you have. So it gives you volume, moving over just a little bit there. 402 point, it says 1.2, it wants us to round to the tenth, so it's 402.1 units cubed. Is it 3? Doesn't really look like it. Again, cubed because we're talking about volume. So when you actually wrote those in, you should have surface area equals 301.6 units squared. Should have volume 402.1 units cubed. Again, a really good idea to get in the habit, if they don't give you a unit, just to write units. Your EOC will pretty much always give you a unit, so just make sure you pay attention to what that is. Don't feel bad if any of these at any point in time you had to go back, rewatch that video, go back into your booklet, look up these formulas. I don't expect you to have these memorized yet. Your EOC will expect you to have them memorized because they don't give you a formula sheet. So be aware of that as you're working on these. Don't just say, oh, I'm going to use these right now and forget about them. That's going to be something we're going to be working on and will come up again and again as we're working through. I'm going to try to cycle back and always remind you, going back and say, okay, we need to make sure we don't forget these. So, surface area, if you remember surface area of a pyramid, if you don't, you can always go back and look. What we had to do is we had to find the area of one of the triangles, one of the triangular faces, and then multiply it by how many faces there were. In this case, there's 4, because all the ones we're dealing with, we're going to be dealing with square pyramids. And then we had to find the area of the base and add it to it. So we're going to start by finding the area of one triangular face. If you'll recall, the area of a triangle is 1/2 base times height. So the area of that one face is going to be 1/2. Again, just plugging in what I know, times my base, which is 10, times my height, which is that perpendicular line that runs down the side of the face here. In this case, got an arrow pointing to it, 13. Which gives me an area of 65. Again, don't have units, so I'm going to say units squared. But that's just one face. I have 4 triangular faces, so I have to take that. We're going for surface area, so we're doing 65 times 4. That gets me all 4 triangular faces, which is going to give me 260 units squared. Still remembering that. But I can't forget that I have that base. So I'm going to find the area of that base, and it's just a square. So that's a length times width. So in this case, 10 times 10. Which gives me 100. But now I have to add those two numbers together. So for my total surface area, I have 260 plus 100. So my final surface area gives me 360 units squared, because I'm dealing with area. That's 2 dimensions. So 360 units squared. Surface area tends to be the one that's most involved, because for a majority of the shapes that we learned, you have to find the area of each face and add them together. Makes it not necessarily more difficult, but you do have to think about it. You don't have just a straight formula that you plug it in. So some of you makes that more difficult. So let's look at volume. Volume is what most people prefer, because again, it gives you that nice, easy formula to plug in. It's just plugging in what you know: length, width, and height. You're going to multiply it by 1/3. So volume equals 1/3 times our length and our width. In this case, they happen to be the same, so it doesn't matter which one you put where. But that's 10 and 10 for length and width. Those are always going to be part of your base. And remember, from the video, I said what's important about the height is the height of the pyramid. It's always going to be perpendicular and drop to the center of the base there. So don't confuse the height of the pyramid with this one. That's the height of one face. I need the height of the pyramid, which drops to the center of the base. In this case, got an arrow pointing to it that says 12. And that's ready for your calculator. You plug that straight into your calculator. You get the volume equals 400. Nice even number. Like it when that happens. So we get 400 units cubed in this instance, because we're dealing with volume. We got 3 dimensions we're working with, so we make sure it's cubed. Don't let a little something like a formula there mess you up. Those are your friend. All you got to do is plug in the information that you're given and solve. Makes things so much easier. So surface area of a cone is another one of those few surface areas that give us a formula, which is good for us because that gives us something nice and easy to follow each time, and we don't really have to think through the process as much. And all we got to do is plug in what we know. Again, we have R. Stress one more time. R is radius, halfway across a circle. So if they give you all the way across, you got to divide by 2. Just keep that in mind. In this case, they only gave us halfway across, so they gave us the radius. A new one here, L. L is the length of the side of the cone. So if you think Pythagorean theorem, that's the hypotenuse of that right triangle formed there. And it's important that we know the length of that. It is possible to find the surface area of a cone without it being given, but that just means it's extra work for you because you have to figure out what the length of L is. We won't really be working with any of those, so you don't have to worry about that too much. Plugging in straight what we know for surface area. Pi times R, a radius is 5 in this case, times radius again, 5, plus L, which is 7. Now, if you're following your order of operations, you know you've got to add those first before you start multiplying. And again, just solving out a little more, that's actually ready for your calculator right here. As long as you use those parentheses. In this case, it is extremely important you use those parentheses first. Okay? But again, as I've been doing, I'm going to show you out step by step how we simplify that. plus 5, times 5 plus 7 gives me 12. So my surface area equals, I'm going to combine that 5 and 12. So 5 times 12 is 60 pi. And again, since I have a symbol for pi, I can almost treat it like a variable and put it there. It's not a variable, but you might see that final answer as 60 times pi because that is what your answer is going to come out to be. But since it's saying round to the nearest tenth, that's generally an indication they want us to give the decimal answer. Helps if I switch back to my pen there. So surface area equals 188. And it gives us 0.49. It wants us to round to the tenth, so that 0.49 becomes 0.5. And it does give us a unit this time, so we have inches. We're talking about area squared. Important to remember those units when dealing with surface area and volume. One big reason I really put such a stress on them is because your EOC is notorious. They love to say, okay, it's the surface area, or I'm sorry, not in surface area and volume specifically, but will give you one measurement and then want you to convert it into another. So they're really not going to be doing that all that much in really probably any with surface area and volume, but getting in the habit of paying attention to what those units are will really make your life easier for later. Now we're going to the volume, which again, I said most people prefer over surface area because it gives us that nice straightforward formula we get to follow where all we have to do is plug in what we know. So we're going to keep the 1/3 pi because that doesn't change. Again, we have r, that's our radius. So we're going to plug in 5 for the r, and it's squared. And then height. If you remember height, talking about the height of the triangle, not the height of the side. Don't get that confused because this is L over here. This is the height. Anytime you've got something, cone or pyramid, that height's going to drop to that center of the base, and that's important. So height, in this case, is 6, and it looks like it says IR. What's actually happened is that's a bad copy, and that's 6 inches. So don't let that throw you off. Doing a little simplifying, 1/3 pi times 25, because we always got to do those exponents first, times 6. And really, even at this step, that's ready for your calculator as long as you're using your parentheses. But as I've done in the past, I'm going to show you those steps, what they look like written out. So that comes out to 50 pi, which gets us a rounded answer of 157.07, but round to the tenth, so that 07 becomes 0.1. Again, that's inches, and we're talking about cubed. So your volume, 157.1 inches cubed. Surface area of a sphere is another one of those they're nice enough to give us a formula for. So what we're going to do is we're going to start by plugging in what we know. Surface area equals 4 pi. That doesn't change. All we got to do is put in r. Remember, r is radius, halfway across. In this case, they give it to us, times 20 squared. Now, I've had people in the past, and I got an email or two over it yesterday. They go, Mr. Mitchell, that doesn't look like it goes to the center. It doesn't matter really how the picture's drawn. They're not going to have you assume anything. So if they've got something along those lines, they're not going to have to try to make you figure that out. So if it's something along those lines that it looks like it's just poorly drawn, it probably is, go ahead and stick it out to the radius. Most of the time they're going to tell you it has a radius of this, or we'll do a little better picture on that. But don't let that throw you off. Again, just simplifying some of that. Alright, so that's what that looks like going through. That's what that looks like going all the way through. Again, having us round to the 10th place. You're going to get very large numbers on spheres because they have lots and lots of, especially with surface area, they have a very large surface area. So don't let that throw you off. Some of these other ones you're going, well, you know, I've got big sides on a prism, but it doesn't have anywhere near that surface area. Don't let that throw you off. Big numbers for the surface area of a sphere are expected. Another one of those lovely formulas where we just plug in what we know. In this case, all we need is the radius equals 4/3 pi 20 for our radius cubed. And again, that's calculator ready right there, but just doing some of the simplifying by hand. I'm going to skip ahead so you don't have to watch me write all this. So there, jumped all ahead a little bit so you didn't have to watch me write all of that going through. So all I did was just work it out. Now remember, you got this point right here, that's calculator ready. You can punch that straight in and jump down to this answer down here. I worked through the steps so that you can see where that comes from, so I don't have any magic answers here. If you did not write all of that out, that is fine and understandable. I would recommend and going to require, didn't say specifically yesterday, but I'm telling you now, that you need to at least write that initial formula for any of them that have formulas. So for example, the surface area of a prism, you don't have to write one because you don't have a formula for the surface area of a prism. But for any of those that you have a formula, you need to write that, at least that initial setup there where you've got the number plugged in. And then if you've got the answer after that that you punch straight in your calculator, I'm fine with that. But that at least gives me an idea whether or not you know how to set those up. So not going to go all the way through all these, but just setting this up. Perimeter to rectangle. You got 25.03. You got 12.374. The trick with this one is remembering perimeter goes all the way around, so this side is also 25.03. And this side is also 12.374. So if you weren't paying attention and didn't notice that you would have to do those sides again and go all the way around, the incorrect answer is one of those on there. So you got to add those up, all four sides. This one wanting volume of a rectangular prism. If you will recall, that is volume equals length times width times height. So it would just be a matter of multiplying the volumes it gives you. So length, width, height, doesn't really matter which one's which. That, you know, multiplication's commutative, so order isn't important. 9. We've got cylinders with a radius of 9 inches and a height of 48, and want you to find volume. Now, volume of a cylinder is pretty easy. You're finding the area of that circle on the bottom and multiplying it by height. So you're going to get volume equals pi r squared, which you guys are pretty familiar with, but then you're just going to multiply it by the height. So you're going to plug in, it gives you r, radius of 9 inches, and a height of 48. So just plug in those two numbers, plug it straight into your calculator. You're good to go. So that final one, it says you've got a cylinder that's being painted. Rest of it really doesn't matter. We know that we need the surface area of the can to the nearest tenth. If you recall, if you don't, you can go back and look that up, or I'm about to give it to you. Surface area of a cylinder is pi d h. Remember, d is diameter, so if they give you a radius, you have to double it. If they give you the diameter when you're talking about the radius here in just a moment, you've got to divide it by 2. So remember those two and how they're related. You got 2 pi r squared. So essentially, when you're finding surface area, you've got the flattened out rectangle, that's the flattened out rectangle, which is this piece, and then you have the area of the 2 circles on the ends, and that's how that works. So hopefully that was all you had to do was set that up and plug those in, and then it's just ready to go for your calculator. So hopefully that wasn't too bad for you. Most of you seem to be alright on it. I didn't get too many emails saying, hey, how do I do this? So let's look at worksheet 40. Now I'm going to point out something on this one. If you remember, I said to always, always, always use the pi key unless you have instructions telling you to do something else. In this case, you have instructions telling you to use 3.14. So when you're using yours, you're going to use 3.14 and then round to the nearest tenth. So make sure you paid attention to that. If you didn't, that's going to affect your answers a little bit. Because pi is not 3.14. That's a rounded version. But in this case, it tells you to use that. Now, something that has in the past thrown people off, and hopefully it didn't anybody yesterday, but I should have maybe warned you that it didn't draw in the radius on some of those cylinders, but it is a radius, and hopefully you figured that out. I didn't get any emails again saying, Mr. Mitchell, what are you doing here? You didn't give us enough. So I'm hoping most of you figured that out, that that's a radius there. If you didn't, it's easy enough to go back now and fix that. I'm going to go through the setup of them on this. So if you had trouble with your homework last night on figuring out how to get it set up, I'm going to help you with the setup, but I'm not going to give you the final answers, because if I give you the setup, you should be able to type it in your calculator and get the final answer. Plus, if I just give you the final answer, I know you guys well enough, a lot of you would just go through and look for the answers and write them down. So, surface area of a cylinder, it's going to be SA equals, it's that same one we used at the end of 39 there, pi d h plus 2 pi r squared. So that's the formula we're using. Then we're just going to plug in what we know. Surface area equals pi times diameter. Now, again, and I'm just going to hammer this to death. Diameter and radius. Radius is half of the diameter. So if I give you a radius, which they did here, you have to double it for this number. So we double that, we get 1.4 times your height, which is 1.5. Does not change anything that they give you decimals. Plus 2 pi radius this time, 0.7 squared. And that's the setup. And again, that's calculator ready, just as it is. If you're going to punch it in your calculator, the only set of parentheses that's really important, you can either hit multiply between those three, it'd be fine, or set up your parentheses. But that parentheses on square and that 0.7 is going to be pretty important. So as I said, that's calculator ready right there. All you gotta do is punch that right in, and that should get you your final answer. All you had to find on these was surface area. All you had to do was surface area. Your next one is a prism. So what we had to do is we had to find the area of the sides and add them together. So you're going to find the area of this first face. I'm going to highlight it to make it a little easier which one I'm talking about. So I'm going to deal with this side here. So it's going to set up length times width. So it's going to be 10, go back to my pen, 10.4 times 5.2. That's going to give me the area of this side. And then, if I count, I'm going to have 4 of those sides. So those 2 there. And you remember I did in the video where I dropped, like we x-rayed the prism to where you could see through it. You're going to have 2 more sides back there. You didn't have to do that. If you can remember, you're going to have 4 of those sides that are all going to be the same. So what I'm going to do is once I find that answer, so 10.4 times 5.2, I'm actually going to multiply that whole thing by 4. Or add that answer 4 times. That's the same thing to get that side. Then what I have to do is find the area of that inside, which is going to be 2.7 times the width, which is 5.2. And I'm going to again realize I have 2 of those sides and have to multiply them by 2. I'm going to add those together. So, to find your answer, calculator multiply that, calculator multiply that, then add those 2 answers together. It's about as simple as I can make it for you without giving you the answers. Now this next one, I know it looks like I gave you something different here, but I didn't. I'm still giving you a prism. Now, that's a height right there. That's important that you know that that's a height. And again, that's another one of those things that's a bad copy and it's actually there, but you can't see it on your copy and can't even see it on my copy. But the actual printed version, you can see it. I don't know why it doesn't show up. So again, it really seems as though I've given you something new here, but I haven't. You're still going to do length times width, or another way to say it is base times height. And that's a good way to think of it with quadrilaterals of any kind, because that takes care of your base and your height. So you have 4.9 times 3.9. And that gives you the area of this face right here. What's important to pay attention to is if you notice that this side right here is not the same. It's 3.1. So we're only going to have 2 of these, one on each side. You're actually going to have those 2 only twice. So you're going to multiply that by 2, being those end pieces. Your 4 that are going to be the same, which is often the case with prisms, are going to be your red sides over there that go all the way around. To find the area of it, it's still length times width, or base times height. Our base is 3.1, and our height is still going to be the same. So you're going to have plus your base times your height, which is 3.1 times 3.9. And what you're going to do is you're going to multiply that by how many sides you have, which is 4. Now again, that's calculator ready. You can punch all that in. If you want to simplify a little bit first and then add your answers, would probably make your life a little easier. But as long as you remember those parentheses, they are important. If you leave them out, you'll get the wrong answer. But as long as you remember those parentheses, you'll be good on those. Couple of quick pointers on this one. It's going to be set up exactly like our last one. So there we got our height again. So you just got to figure out which ones you have 2 of and which ones you have 4 of, if you have any. And it's an important distinction to say if you have any, because sometimes you have 3 sets of 2. perfect example being this one is even more obvious. I'm going to have these two end pieces are going to be the same, these two narrow pieces are going to be the same, and these two broad pieces are going to be the same. So I'm going to have three sets of sides that are the same. And what's actually going to happen is I'm actually going to have that on this one as well. So what I'm going to have to do is set up base times height for this first one, base and height. So I'm going to have 11.4 times 7.2. In this case, I'm going to multiply it by 2 because I'm going to have two of those sides. Plus base times height again is going to be, again, I'm going to have two of those sides. 2 times 2.3 times 7.2 plus this side up here. Now it's got a width of 2.3 and a width of 11.4. And I'm going to have two of those sides. So I'm plus again 2 times 11.4 times 2.3. Again, that's calculator ready, and you've got to pay attention to what sides are the same here. There's so many of them we've done already that it has 4 that are the same and 2 that are different, but that's not always the case with a prism. You've really got to pay attention to what's going on there. Number 5 is set up almost exactly the same way, so I'm not going to go through the whole setup there, but you're going to multiply length times width on this side, length times width on this side, and then length times width on this side. Again, another way to think of it is base times height. Number 6, just a real quick recap on that cylinder. It's exactly like number 1. You're going to do, that's just going to be surface area equals pi times d, which is going to be doubled your radius. Remember, that's important that you always have that. So that's, in this case, going to be 13.4 times your height, which is 12.9, plus 2 times pi r squared. R is 6.7. An extra set of parentheses in there that I don't need. 2 pi times r, which is 6.7 squared. And again, that's calculator ready if you want to punch that in just as it is, or I would probably simplify it a little bit first and do this part and that part and then add them together just to make your life easier. Number 7 is another one of those prisms that's a little bit different. Again, that height the line didn't draw in very well, but it's 6.4 millimeters. So make sure you've got that when you set up. So what you'd have here is you have two faces that are the same on front and back. You have those two triangles that are going to be the same. These two sides are going to be the same because you can see that this is an isosceles triangle, but that base is going to be different. So what you're going to have is you're going to have two triangles you find the area for, and you're going to have 3 rectangles, 2 of which will be the same. So you set that up, you got your area of your triangle, which is base times height. So you're going to have base times height 6.4, excuse me, 1/2 base times height, misspoke, 1/2 times 6.4 times 6.4. I already said I'm going to have 2 of those, so I can multiply it by 2. Plus my rectangles here. So I've got length times width on those, and I have 2 of them, so I'm going to multiply by 2 times 8.3 times 6.6. And then finally that last triangle down, or excuse me, rectangle down here at the bottom, plus parentheses 8.3 is my length times my width is 6.4. And again, that's calculator ready going all the way across there. You don't have to try to set these up multiplying them. What I could do is I could find the area of that rectangle, find the area of that triangle, find the area of this rectangle back here, find the area of that hidden triangle back there, find the area of the base, and then add them all together. You don't have to do them separately. You can, excuse me, you don't have to put them all together. You can do them separately. The next one, it's all squares. So all the dimensions are the same. So find the area of this one side here, which is going to be 4.3 times 2, or 4.3 times 4.3, and then multiply that by 6 because you have that 6 sides. This last one is the only one that is actually different, and one that I didn't give you, and I gave it to you as a challenge problem to see what you would do with it. If you did it, great. If you didn't, I'm getting ready to do it, and you should copy it down. This one's perfectly fine. I'm going to go through the whole thing all the way to make sure you've got it all set up right, and then you can punch in the last little bit on your calculator. The only part that is any different than what we've done is this first face right here in front and back, which are going to be the same, by the way, but it's a trapezoid, and I haven't gone over how to find the area of a trapezoid. Now, if you saw that it was a trapezoid, and you went on Google and Googled how to find the area of a trapezoid, it gave you a pretty straight formula. Now, I told you specifically not to do that for your solid shapes, so if you didn't do that, I understand. But here's how you would set that up. You find the average of your two bases, your upper base and your lower base. So you're going to do 8.6 plus 12.8 in parentheses, because I want to do those first, divided by 2, times the height, which is 7.9. That gives me the area of one face, gives me the area of this blue face here, or excuse me, this red face here. And once I have the area of that face, all I got to do is multiply it by 2. So instead of trying to give you one big complicated thing to do by 2, I'm going to go ahead and solve that for you. So I got that solved out for you. Now notice, I know it says to round to the nearest tenth on all of these, but you only want to round the last answer. I don't want to round this answer and then round again later and then round again later. You want to only round once, because that'll give you the most accurate answer possible. Then all you've got to do is find the length of the rectangles. Or excuse me, I'm going to almost skip a step there. So that's that one, but then you got to double it because you got another trapezoid on the back. So times 2 equals 169.06. There is a 9 there. No, it doesn't really look like it. There we go. So that's the two trapezoids, and then all I gotta do is find the rectangles. So this one's going to be 8.8 times 6.3. And it does appear that there's a match to it on the other side. So I'm going to do that times 2. And I'm going to get added to all this, and I'm just going to make a kind of a list what all to add together. So 110.88, that's the length of, or the area of those two rectangles. I'm going to find the area of the top, which is going to be 8.6 times my base down here. It's still the same, it goes up here, so 6.3. I only have one of those, so I don't double it. And add to my tally here 54.18. And then I find that bottom one, which is going to be those two dimensions, so 12.8 times 6.3. And again, I only have one of them, so I don't double it. And I get 80.64. What I'm going to do is I'm going to add those four numbers together to get my total surface area. which gives me a total surface area of 414.76. It says around to the tenths place, so that's going to become an 8. So that'd be 414.8 centimeters squared, because we're talking about surface area. So if you didn't get that one was a challenge one. It was intended to be a little harder, and it was more just me seeing what you would do with it if you've come across something that's a little unfamiliar. So it doesn't count against you unless you don't copy it down off this video. I mean, I wrote the answer in for you, so if you can at least write down the answer, then you deserve to have points taken off for not copying down the answer. Okay? Make sure you do that one. You've got more work today on this, and hopefully this has made sense, or makes a little more sense now that I've gone over it. If you have more struggles with it, feel free to rewatch this video, rewatch the video that with the booklet that goes through the formulas, how to use those. Feel free to go back and look at your booklet. You should get those back if you haven't already. And as always, if you have troubles, you can email me. I will try to get back to you during your class period. If not, I will get back to you as quickly as I can. Have a good day, guys.